Next, and well, last but not least, is our technique known as isoelectric focusing, or IEF. Isoelectric focusing is a protein separation technique, and what it allows you to do is separate proteins on a pH gradient, and they are going to move until they reach their pI. So the gradient is established using molecules known as polyantholites. And so you can have a gel that has a pH range from pH of 9 to pH 7, and it's all these polyantholitic molecules that are going to enable you to have these different charges. So then your protein, right here, can begin separating, and well, lo and behold, you get two proteins in there because one has a pI of 8.1 and the other has a pI of 8.3. IEF, or isoelectric focusing, is the first step or dimension in 2D SDS page, or two-dimensional page analysis. And after separating proteins based on a pI, they're further separated by molecular weight through SDS page. Okay, so isoelectric focusing is an electrophoresis technique that separates proteins based on our pI, or isoelectric point. Remember, your pI is where protein has overall charge of 0. IEF can resolve proteins differing in pI values as little as 0.01. So you can separate a protein that has a pI of 8.01 from 8.03 or something like that. You can get separation of those. The pI of protein. Another use for isoelectric focusing is for fractionation and an alternative to strong cation exchange fractionation prior to mass spec. So I would say more common than not is you're just separating proteins until they reach their PIs. This technique was discovered in 1975, or it was developed in 1975. It was first presented in 1954. The concept of it was first presented. Now, this technique might seem fairly esoteric and abstract, but this is a technique that actually can be used in a number of different ways, because what you can do is you can detect how a protein is modified. For instance, if you have a protein that gets phosphorylated, well, then that phosphorylated protein is going to have a phosphate group, which is going to have two additional negative charges. Those negative charges are going to have an impact on the overall charge of that molecule, and therefore it's going to have an overall impact on the pI of a protein. Glycosylated hemoglobin, for instance, is a reliable indicator of blood sugar, but more kind of specifically, isoelectric focusing is used in the agri-food industry as one of the assays listed in FDA's points for protein quality control in many different foods and canned products. So you can detect, whether or not a protein's been highly oxidized or something. This protein is going to detect proteins and their pI values. This can be used to detect minor changes in a protein, such as phosphorylation or glycosylation, which could impact the overall pI of a protein. You can separate based on proteins of similar size that would otherwise be unresolved in SDS page. So you can see, two identical proteins, or seemingly identical proteins in an SDS page. They're both 55 kilodaltons, but one has a pI of 7.01, the other has a pI of 7.56 or something. You'd be able to get that separation. All right, well, that wraps up all the different techniques. Thank you guys very much for doing these. They've turned out great. Have a good one.